In our research, we studied the origins of bandgap bowing effect in the common-anion transition-metal-dichalcogenide ternary alloy. The structure consists of one metal atom sandwiched between two sulfur atoms, in this case of molybdenum disulfide. The thickness of the monolayer is 3 angstrom and the interlayer distance between two adjacent layers is 3 angstrom as well. In our study, we used quantum-wise ATK. We started by the monolayer molybdenum disulfide MoS2. We optimized the structure and we ran our calculations. Then, for us to study the alloys using different compositions of X, in both cases of common anion or common cation, we simply changed the atoms and we optimized the structure at each time. In the case of common anion, we simply changed the metal atom to the desired one, in this case from molybdenum Mo to tungsten W. And then we optimized the structure again and we studied the properties. We repeated the same procedure for different compositions of tungsten, different values of X. In the case of common cation, we simply changed the chalcogenide atom from sulfur to selenium. Then we optimized the structure again and we studied its properties. We repeated the same procedure for different compositions X of the selenium atom. By first running band structure calculations and calculating the energy gap of each structure. In each case, we found a direct band gap at the special K point, which was in line with the experimental values. We plotted the energy gap versus the composition X for both cases of common cation and common anion, where the case of common cation showed a linear relationship between the energy gap and the composition. The common anion case showed a bowing effect. Further investigations included the study of the amplitudes of the highest occupied molecular orbital and the lowest unoccupied molecular orbital eigenfunctions. We noticed that the common feature between all structures that near the band edge, the eigenfunction has the characteristics of non-bonding states, and they are confined to the metal plate. We must emphasize that in the case of common anion, with tungsten 25%, the LUMO state does not have any contribution from the W atom, and the LUMO is accommodated by MO atom entirely. This competition is considered as one of the main reasons causing the bandgap bowing in the common anion TMD. This competition is absent in the common cation case since they are made from the same metal.